In software engineering, we are taking numericals and MCQs on software maintenance. Which of the following is a type of software maintenance in SDLC? So in software development life cycle, all of the above, there are 4 types of basically the software maintenance: corrective maintenance, adaptive maintenance, perfective maintenance, and one more is there, that is preventive maintenance. So the answer here is all of the above. So this corrective maintenance is all about bug fixing, identifying and rectifying an issue. Then we have the adaptive, that is changing environment, so maintaining the usability of the software in changing environment, adapting to the environment. Perfecting is improving the performance and the maintainability of the software or the software product or a system. Enhancement, actually, sometimes we enhance the feature also. Then we have the preventive. This is routine checking for issues, problem, defect or failures, so that the software doesn't fail, the software doesn't crash. So as I said, there are 3 basic types of software maintenance. Just add one more, which is called as the preventive also. What are the major factors that affect software maintenance? So let us see what all these are. Let me tell you the answer first. The answer is B. B means 1 and 2 both. The degree of change in the functionality and cost of maintenance. This is one of the major factors. And dangers in undertaking any actions or updating. So if you take this software, now you are changing somewhere. It may happen that the error may propagate. That is, if the coupling is very high, it may happen that the more bugs can come. So the activities associated with the software maintenance project, you see, they are majorly dependent on the degree of change to the item required, the assets accessible to the maintenance team, and also the normal undertakings, danger, and so forth. That is, the major factor is all these, cost and all these factors. Which of the following software maintenance process models is used when little changes are to be made in a software? So just cosmetic changes are there. So there are different kind of software maintenance process models. There are primary, there are secondary, there are tertiary. So if you just small changes are there, then the answer is simply the primary model. So in primary model, there is a way we do it. This is favored for tasking including little revises, which the code is changed straightforwardly and progressions are reflected in the important reports later. So we gather the change requirement, we analyze the change requirement, then we devise the code change strategies, and then we apply the code change strategies. Then we integrate and test, and then we also update the documents. So this comes under the primary model when very minute or small changes are there. Now the same question in a different way, that is, now we are talking about the major changes. Which of the following software maintenance process models is used when major changes are to be made in software? For example, design level changes. For that, we are going to use the secondary model. Which model? Secondary model. So what do we do here? The secondary process model for maintenance is favored for projects where the measure of revise required is significant. So we do the reverse engineering. So we only have a code, nothing else. So then we try to create the design, extract the design, and then we try to find out the requirement specification. Then the requirement specification are added with the new requirements. So now the new requirement specification is there. So the first part is called the reverse engineering. Then the new requirement specification, again we create a design and then code. This is called the forward engineering. This reverse engineering plus forward engineering is called the re-engineering. So this is the secondary model. Which of the following statements is true? So we are talking about re-engineering. So let me tell you the answer first, then I'll give you an explanation. So the answer here is both 1 and 2 are true. That means C is the answer. In software engineering, reverse engineering cycle is followed. In re-engineering, of course, and in software engineering methodology, forward engineering cycle is followed. So we have a code, we don't have any support. So what we do, we create a design. Then from design, we create the SRS. This is called the reverse engineering. Then now we have different changes, modification to be done. This is combined with these SRS which we have extracted. And then now we have a new SRS. Now we create a design and then finally we code. So this is the whole process of forward engineering. And before that we have reverse engineering, and we combine it, call it as software engineering. So both are true here. So this is the process I am telling you. Software, we have existing software, we would do the reverse engineering, then we restructure, then do the forward engineering, and finally the re-engineered software. So this I already told you. Which of the following statements is true? Okay. Now, we have just seen about the reverse engineering and the forward engineering. So, reverse software engineering, why we do it? If we don't have document, if we don't have design, if we don't have supporting documents or even the people or the old system, then we have to do the reverse engineering. Otherwise, there is no need to do the reverse engineering. Okay. So, we just have the code and without any support, so we have to do certain things which are required. So here, the answer here is, because you have to read both of them, reverse software engineering cycle is done when the client's need, old code, etc. are not available. So only one is true. When the support is not available, then there is no option but to know the software, to understand the software, to learn the software and create the code. From the code, create the design and the SRS. Okay. If we have everything, we don't need to do the reverse engineering and forward engineering. We can easily understand the situation and then we can fix the bug, or you can maintain it with certain modification or changes which are required here. So it is not available, we have to do the reverse software engineering. So the answer here is only one is true. Same thing, same discussion lies here, and you can also read this. So reverse software engineering cycle is done when the client's need, old code, etc. are not available. So what is the availability of the software with following reliability figures? So we have mean time between failure, which is 20 days. Mean time to repair is 20 hours. 20 hours. So let me give you the answer if you just want to do it yourself. So let me just give you an answer. And then I'll tell you how we compute it. The answer is 96%. See, the availability is simply the MTBF by MTBF plus MTTR. Availability has a very simple formula. Mean time between failure divided by mean time between failure plus mean time to repair. Mean time to repair. Okay. Now, since the values are already given, the only thing is that units are not same. Availability is probability, so it's going to come between 0 and 1. In the percentage wise, 0 to 100. 0 to 100 in percentage wise. So first is this, as I said, if you want probability, then it is okay, otherwise multiply by 100. Okay. So 20 days are there, MTBF, and 20 hours is the MTTR. So either you convert 20 hours into 20 days, means hours into days, or days into hour. The best way is to convert the days into hours. Now 20 is there. Now 1. So both ways you can do. But the best way is to convert the days into hours. So in one day there are 24 hours. So this 20 will be 20 into 24. So in MTBF we are going to put 20 into 24. Similarly in the denominator you have MTBF 20 into 24. And then you have 20 as the MTTR. Now just compute it. You will get 0.96 multiplied by 100. You will get 96%. Regression testing is primarily related to. Okay, you will be tempted to answer the fourth one, because most of the time the regression testing is required everywhere in maintenance, because maintenance is all about change. But the thing here is the answer is somewhat different. I'll give you an explanation for that. The answer is functional testing. See, the functional testing. What is the purpose of regression testing? This is to confirm that whatever changes you have done, the recent program or code changes, has not adversely affected existing feature, has not created any kind of, say, side effect. So regression testing is nothing but a full or partial selection of already executed test case that are re-executed to ensure existing functionality work fine. So this testing is done to make sure that the new code changes should not have any ill effect, side effect on the existing functionality. It ensures that the old code still works once the new code changes are done. Now we have the question here. Number of line of code required to develop an application is L2, is thrice the line of code in language L1. Also, software has to be maintained for next 10 years. Various parameters for two languages are given below to decide which language should be preferred for development. So maintenance is going for 10 years. L1, LOC for language L1, L2, L1, L2. So we have the parameters. So we have parameters man year needed for development. L1, L2 is also given. Development cost is given 70k and 90k. And cost of maintenance here is around 1,40,000. So total cost of project include cost of development and maintenance. So D plus M cost is added. What is the LOC for L1, for which the cost of developing the software with both languages must be same? Okay. So just try it yourself. Otherwise, I'm going to tell you the answer. The answer is this 3,000. How do we get this? Okay. See, the total cost of the project is total development cost plus total maintenance cost. Okay. This we have to do. Now for L1, let us say the line of code is P1. P1 is the line of code for L1. And for language 2, let us say the line of code is P2. So what is the total cost of the project using this L1? See, line of code, because LOC by 1000 is already given. Okay. So you have to multiply LOC, this P1, that is P1, by 1000 into 70,000 plus 1 lakh, but this is going for 10 years. Okay, maintenance is for 10 years. So total development cost is the P1 by 1000 into 70,000 plus 1 lakh into 10 years, that is for maintenance. Similarly, we'll do it for L2, that is line of code, which is P2, which we just discussed. P2, we can just call P2, P2 by 1000 into the 90,000, because the development cost is 90,000. And then this is 40,000. So 40,000 into, because it is going for 10 years, so 10 years. Now this is the total cost for project L1, but total cost for project L2. Now you see, from first you have to find out P1, from second you have to find out P2, because we have a relationship between P2 equals 3P1. So these expressions which I just told you, the total cost is already given. Okay. So what you have to do is, from first you have to find out P1, from second you have to find P2. Now just equate this, you will get P1, which is 3,000. Given below are two statements. Statement 1 is, statement 2 is also about, first is quality control, the quality assurance. So quality control involves the series of inspections, reviews and tests used throughout the software process to ensure each work product meets the requirement placed upon it. So the answer is both 1 and 2. As I just said, quality control we have just seen. So quality control, quality assurance. Actually, quality assurance is for the management part. So quality control is about inspections, the reviews, different tests. In software, there are different kind of tests: unit tests, integration tests, regression tests, system tests. This is done throughout the software processes. That is, every work product, it can be document also, it can be code also, meets the requirements placed upon it. This is quality control. But what is quality assurance? See, quality assurance is about the auditing and reporting functions of management. In light of these statements, we see that statement 1 and statement 2 both are absolutely correct. So both statement 1 and 2 are true. So in the quality assurance, we do the auditing, and actually quality assurance is assuring yourself and the stakeholder or the user that yes, we have done the quality checks. We are quite sure that we have maintained the quality. And when how to control the quality, we are just tracking and not knowing the progress. We are actually controlling it through various means, which I am saying inspection, reviews, and test. So quality control, quality assurance, all the discussion is also given here. You can just read it here. Software reliability is described with respect to. So how do we describe it? The answer is all the three. That is ABC. So option number 3 is correct. Because software reliability is execution time also, calendar time also, clock time also. So if you see the MTTF and MTBF, MTBF is the actual clock time we are talking about, and in MTTF we are talking about the calendar time. So this reliability, the reliability is the probability of the software working correctly for a specified period of time. Okay. So execution time of a program is the time that a processor spends actually executing the program's instruction. The second time, which is a calendar time, it is a familiar time what we normally see and experience. Clock time is the normal wall clock time. So software reliability is described with respect to all of these: execution time, calendar time, and clock time. As I just suggested, software reliability, like hardware reliability, is defined as the probability that the software system will work without failure under specified condition for a specified period of time. So you can just say that it is working correctly, or it is not failing, working without failure, or it is providing its required functions. MTTF, execution time. MTBF, the time is the calendar time. Statistical software quality assurance in software engineering involves. So statistical software quality assurance, let us see the answer first, then I'll tell you. The answer is 3. That is, first we trace each defect to its underlying cause, from where the defect has come. The software quality assurance means that only. Then we isolate the vital few causes or the reason for this defect, and then we are moving to the idea of correcting them. So here we have a Pareto principle. Pareto principle means 20% of effort can give you 80% result. So the statistical software quality assurance in the software engineering involves tracing, then tracing the defect, and finding the cause, and then correcting it. So this statistical one uses the Pareto principle to identify the vital causes, that is 80% of the defect can be traced from 20% of the causes, and moves to correct the problem that have caused the defect. So this is Pareto principle underlying, but basically statistical, the answer is 3, because what we are doing here is already known. Modifying the software by restructuring is called. Restructuring means, see, the answer is perfective maintenance. Why we are doing the perfective? Because we want to make it perfect. That is, we need to change the design. We need to change such that there is no failure. That is one thing. But still, for example, file transfer 1 GB 1 second is taking. We want 1 GB in 0.1 second. So that is perfective maintenance. So there is a major restructuring going on. Okay. So we already talked about the corrective, adaptive, and perfective, and the preventive also. So perfective maintenance, as I said, changes in the software that occurs as a result of adding new features. Perfective. Also enhancement. Also you can say the performance enhancement, and making the software more rugged, more strong, more stable, more mature, more quality wise improved. This is done in perfective maintenance. A software project was estimated at 864 function points. So FP is 864. A 6-person team will be assigned to project consisting of a requirement gathering person, one designer, two programmers. So designer, the salary is 70,000. The requirement gatherer salary is 50,000, and programmer is 60,000. We'll call it as K. So 60K, 50K, 70K. And these are the average productivity for the team is 12 FP per person month. That is, one person in 1 month produces 12 function points. So average productivity of team is 12 FP per person month. So which of the following represents the projected cost of the project? So ultimately we have to find out the projected cost. Okay. Now let us see how do we get it. The answer is 43 lakhs 20,000. Let me tell you that 10 lakh is 1 million. So you can understand like that. Okay, all these given points we have already written. So let us know it once more. FP is 864, team 6. The average each person FP productivity is 12, and the salary is also given. So we have 12 FP per person month, and then we have the salaries. And since we have 2 programmers and 2 testers, the designer salary is 70,000. So the programmer there are 2, so 2 into 60,000. Tester also 2 into 60,000, and requirement gatherer is 50,000. So the total number of months first we have to find out. And if you are not able to remember the formula, you can easily do using the units. And the months will come when? The months, because the 12 FP per person month is involving the person month, and the 8664 is involving the function points. So FP get cancelled from here, and we have around 6 person. So we have to put 864 functional point in the numerator, the team, that is the person, in the denominator, and the average each person FP productivity in the denominator. So A64 divided by 6 into 12. So I have just done it using the unit method. I know the unit, which unit is going to cancel. Okay. Now just add the amount, total cost of the project. Just add the salary, 73,000, 2 into 60K, 2 into 60K, 550K. I multiply it by 12 because 12 months are there. This answer will come. In SCM, software configuration management, which of the following is a use case supported by standard version control systems? Okay. Which of the following is a use case supported by standard version control systems? So let me tell you the answer, then we'll have a discussion on this. The answer is 1. Only A, C and D. SCM is all about change control. Changing. So managing several versions or releases of a software. This is true. Then we have the C1, allowing team members to work in parallel. And then we have identifying when and where a regression is encountered. So in SCM, we develop the next version of a piece of software while fixing problems with the current one. We share code with other team members in a controlled way, allowing us to develop code in parallel with others and join with the current state of the code line. And then we identify what versions of code went into a particular component. Then we analyze where the change happened in the history of components development. So we have the change control, we have the version control, we have the auditing, we have the reporting. There are different objects, software component, the configuration objects, software component, the items. Then we have the baselines. So all these are there, but the answer here, filing bugs and tracking their progress is not the part of SCM. Though bug is already there, it can be tracked. A product has MTBF of 200 hours and an MTTR of 10 hours. What is its system availability? So we have already done a question like this. So we just have to compute these MTBF by MTBF plus MTTR. It is given in the same unit. So you don't have to change the unit also. So 200 by 200 plus 10, this is the answer, 0.95 will come. So if percentage has been asked, multiply it by 100. Changes are made to the system to reduce the future system failure chances is quad. So in order to stop the later failures, what we do? We do the preventive maintenance. Okay. So changes are made to the system to reduce the future system failure chances is called the preventive maintenance. That is, we want that the fire should not happen. Okay. Preventive is the fire has happened. Now you need to extinguish it. So preventive is all about routine checking for issues and failures. So the system does not fail. You can reduce the chances of failure. So these are all different type of maintenance which you see here. So preventive is modification of a software after delivery to detect and correct the latent faults in the software product before they become effective faults. Which of the following steps is not related to booting? Now this question just I have added here. A system is already running but needs to be started. So this is not related to booting, because switching on power supply is a part, loading operating system into computer's main memory, this is the part, and keeping all application in a state of readiness needed by the user. See, this is also a part of booting. So the startup first or on self-test, BIOS, initial test is performed by the BIOS, loading of OS, then the system configuration, then loading the system utilities, and then the authentication, and then you can enter and start the work. So when the system is already working, the system is already running but needs to be started is not a part. The test suite, that is the set of test input used to perform unit testing on a module, could cover 70% of the code. So this is a test case. It can cover 70% of the code. Now what is the reliability of the module if the probability of success is 0.95 during above testing? So 0.95 is the success and 70% is the code coverage. So you just have to multiply them. The answer is 0.665. So how it has come, let me just tell you. See, software reliability, what is this? It is the probability of error-free software operation in a given setting over a given period of time, or you can say the probability of correct working of the software. The software is working correctly. So 70%, the set of test input used to perform unit testing on a module covers 70% of the code. So we need to find out the reliability for that module only. The reliability is simply coverage into probability of success. Multiply them, you will get 0.665, and in the percentage it is 66.5 actually. A signal processor software is expected to operate for 91.25 days after repair, and the mean software repair time is expected to be 5 minutes. So mean time to repair is 5 minutes, and the signal processor software is expected to operate for this much day after repair. So this is the mean time between failure, I guess. So the availability of the software is what? So both the things are given to us. MTBF, availability is uptime by uptime plus downtime, or you can say MTBF divided by MTBF plus MTTR. So 91.25 is uptime, 91.25 is uptime, and you divided by plus 5. But there is a catch here, because you have to convert these days into minutes, or you can convert 5 minutes into days. So need to convert it. So what you can do, 91.25 multiplied by 24 hours and then by 60 minutes. Now you put it here. So same thing is done here. 91.25 into 24 into 60 divided by 91.25 into 24 into 6, 60 plus 5. So same thing is done here, just convert it, and you will get 99.99. In percentage it will be 99.99, 62 to be very precise. Software reengineering is concerned with, okay, I want you to read all this and just try to get the answer. The answer is third one. Software reengineering is reorganizing and modifying the existing software system to make them more maintainable. So you need to convert or change, modify the software. Then you don't have any old software, you don't have any supporting document, you don't have any support also. But the cost of changing the software is quite high, but cost of maintaining is low. So the better way is to maintain it. But in order to fulfill the change, you have to start with the code, do the backtrack, that is reverse engineering, to find out the design via, and finally the software requirement specification. And when you have the software requirement specification, you have to do the forward engineering again. That is, from the requirement specification, you have to do the design and the code. So this whole is called the software re-engineering. So reverse engineering followed by the forward engineering. Now your system will be more testable, more maintainable. It will be perfective also. So this is how the quality is increased. One more thing is that this re-engineering has a lot of activities. So the documents will also get changed depending upon what you have changed. If in a software project, the number of user input, user output inquiries, files and external interfaces are this much. With the complexity average weighing factor. So we'll use the average part. The productivity, it's given as 70 person-month. So this is the effort being given. Okay. So the answer here is 408.74. Now I'll just tell you how to do this because we are going to use the function point analysis here, FP analysis. How do we do this? So we have to find out the input domain functional units. And since this is already given, EI, EO, EQ, ILF, EIF, this is given. 15, 50, 24, 12, 8. Now weighing factors is already given. So this average middle one you have to use. So the middle column and this 15 till 8 you have to use, multiply them one by one and just add them. And that is going to be your final function points. So 4 is given, 4, now multiply 4 with 15. I am taking this one. Just convert it into the column and multiply the middle column with this column. 4 into 15, then 5 into 50. This I am taking 50. Then 4 into 24. 4 into 24. Then 10 into 12. Then 7 into 8. Multiply and add. So when you add them, you are going to get 582. So what is the productivity and productive month? This is 70. So we have to find out the person. The answer should be coming only when you have the 582 as the value and the 70% is already given. So multiply it with 70%, you'll get 408.74, of whichever is the answer. Configuration management is not concerned with. Configuration management is all about controlling the change, and there is auditing, version control, so many things are going on. So the choice of hardware configuration for an application is not there. Controlling changes in the source code is there. Controlling documentation changes. Maintaining versions of the software, that is the version control. And there are so many activities. We actually have nowadays the software, configuration management softwares. The extent to which the software can continue to operate correctly despite the introduction of invalid inputs is called as. Is it the robustness? See, you are trying to give invalid inputs. You are trying to break the software, but still the software is not breaking, and that is called the robustness. So the extent to which the software can continue to operate correctly despite the introduction of invalid inputs is robustness. That is, you are trying to break. You are trying to give those inputs which you know that it is going to deteriorate the software, or wherever it will, some errors may come. Sometimes the software should also show the graceful degradation if things happen like that. Fault tolerance is also one of the part. In context of dependability in software engineering, the ability of the system to deliver services when requested is called dash. And the ability of the software to deliver service as requested is called. So the ability of the system to deliver services when requested is availability. When I want, I need it. When I want, if you go to a shopkeeper, you want something that is not available, he will say not available. That is availability. And the ability of the system to deliver services as requested, that is the functions are already, these functions of functionalities are being provided to you or given to you by the system. This is called the reliability. So there is a very small change in the definition. So availability and reliability. So availability is the probability that a system at a point in time will be operational and able to deliver the requested services. And reliability is the probability of failure-free or error-free system operation over a specified time in a given environment for a given purpose. Okay, this is all about this discussion. Thank you so much.